Hello everyone, let's start with the third module of your power system analysis one subject that is symmetrical components. Let's get started. Before getting into the syllabus, we need to have some basics, right? Basic knowledge, common concepts already we discussed in the second year and then first year subjects. So in the first year subject, we discussed star connected load, delta connected load, star connected synchronous generator, delta connected synchronous generator, how exactly electricity is generated in the three phases, and three phase winding and then single phase winding, single phase supply already we discussed. So symmetrical components, we have three components, that is already we discussed in the theory concepts in the basic electrical. So this is electricity produced from the R conductor, this is from Y conductor, this is from B conductor. All the conductors are placed 120 degree apart each other, 120 degree apart each other for balanced power supply, VA, VB, VC with respect to time will be there. Okay, so we have discussed and phasor diagram also we discussed, like this is VA and then this is VB and then this is VC. If you take I mean this one is a unbalanced phasor. Here we are choosing this angle is not equal to this angle and then this angle, so that's why it is unbalanced. Phase angle is different, also impedance also different, that is unbalanced phasor. So from this we have three symmetrical components, that is positive sequence components and negative sequence components and then zero sequence components. These components is called as a symmetrical components and are symmetrical phasor components. Is a positive sequence components. This one is clockwise direction, this one. This is anti-clockwise direction. So negative sequence component, and then zero sequence component as a straight line. I mean there is no phase angle phase difference. All the phase sequence components placed 100 degree apart each other, that is called as balanced positive sequence component, balanced negative sequence component, and then this is zero sequence component. VA naught plus then VB naught and then VC naught are equal. See here A B C, so A B C is a clockwise direction. So see that the symbol must be like this, and the symbol like must be like this, A C B. If suppose if you take like this, A C B, A after that C, after that B. This one if you take like this, A B C. Otherwise if you take like this symbol also, A B C, A after that B, after that C, and then A C B. This is positive sequence, this is negative sequence, this is zero sequence. That's why it is called the symmetrical components. So symmetrical components, this is one waveform, another one waveform, another one waveform, like sequentially it will be occurring. Okay, the next concept is the A operator. So the A operator, in some of the books they mentioned alpha operator, A operator. So already I told you, so A is called like one angle 180 degree, that is e raised to j 120. So VA, the phase difference with VB is 100 degree, so that is A operator, that is cos 120 plus j sin 120, you will get the value like this. If it is A square, A into A, you will get the value like this, and A cube, if you substitute A and A square into A, you will get A cube, and then 1 you will get it. I directly get 0 minus 0.5 plus you will get square in the sense I mean addition of those two will get it only 1, so plus minus will be cancelled and then we will get 1, and then A cube also is equal to A, and 1 plus A square. This is very important equation for our calculation purpose, and A conjugate is equal to A square, A minus A square is equal to j root 3, A square minus A is equal to minus j root 3. This is a conjugate like plus and minus. So let's talk about your concepts. So VB1 and then VA1, in terms of VA1, that is 240. So VA1 is here and then VB1 is here, and then this is VC1. So if it is if you want VB1 in terms of VA1 is a reference, 240 degrees required, here 120 is required. So that's why VB1 is equal to A square is 240, A is 120, V square A VA1. So VBT is equal to A VA2, VC2 is equal to A square VA2, VA0, VB0, VC0 are equal. This is a zero sequence component. This is positive sequence, negative sequence, zero sequence. This is positive sequence component, negative sequence component, zero sequence component, zero sequence symmetrical component. Okay. So since it's a there is a unbalanced phasor, VA, VB and VC can be resolved into three sets of balanced phasor. The phasor VA is equal to the sum of the positive sequence components and of even phase A, and the negative sequence component VA2 of phase A, and the zero sequence component VA0 of phase A, that is VA is equal to VA0, this equation, and then this equation. So if you multiply A operator here, VA0, VA1, this is equal 1 1 1, will get it, A square AVA. So substitute before I mean previous slide, A and A, but is VA, VB2 substitute, and whatever VC2 substitute, will get it this equation. In terms of matrix form, we got this matrix VA VC is equal to 1 1 1 1 A square A, 1 A square, VA0, VA1, VA2. So this is a symmetrical components in terms of phase sequences. So if you want to calculate expression of symmetrical components in terms of phase voltages, so symmetrical components in terms of phase voltages, this is phase voltages in terms in terms of symmetrical components, already we discussed. So this is a T matrix. So this is symmetrical components in terms of phase voltages in terms of symmetrical components. Okay. Next we will discuss expression for symmetrical components in terms of phase voltages. This is a symmetrical components, this is the phase voltages. Symmetrical, I mean phase voltages, symmetrical component. So these are the positive sequence component, negative sequence component, zero sequence components. So we will get it, all the values from this one. So if you want to calculate A inverse adjoint of A divided by determinant of A, everybody knows from the matrix formula. So if you want to calculate determinant, you will get this equation. This is a mathematics, adjoint of T also mathematics. So not required, I guess, the mathematics equations simplifications. So after the simplification, we will get the equation like this. So 1 by 3, 1 A square, 1 A square A. So this is the equation, we will get it. So phase sequence component, phase sequence components, these are the symmetrical components. So finally we got this one is matrix is inverted. So 1 1 1 1 A square, 1 A square A. If suppose if you want A Y A B C, there is no 3, and then only you will get A square A square. So general form equation, very important for solving the problems. VA0 is equal to this value, VB0, VA1 is equal to this value, and then VC0, VA2 is equal to this value. This is zero sequence, positive sequence, negative sequence, zero, positive, negative sequence components present here. And then voltage over, and next there is a current. Current is IA, IB, IC is a symmetrical components. These are the phase sequence components. I mean like IA positive negative sequence, zero sequence, positive sequence, and a negative sequence components. This is a matrix for symmetrical components in terms of phase sequence components, and then phase sequence components in terms of symmetrical component. 1 A, 1 A square, 1 A square A. See here, this matrix only inverted. Okay.